Welcome back, mathematicians. In this video, we are going to discuss radians. Radians represent another way of measuring an angle. So at this point in your math career, you have likely used degrees to represent angles. We are now going to introduce radians as an alternative way to measure angles. The radian measure, theta of an angle, is the measure of the ratio of length of the arc it spans on the circle to the length of the radius. In a more concise way to write it, you have theta, which is the angle in radians, is equal to the arc length over the radius, and we let the variable s represent the arc length, and we let the letter or variable r represent the radius. To give you a diagram of what this means, if we were to put an angle in standard form where the initial side is on the positive x-axis and the terminal side, let's go with in quadrant number 1, S would represent the length of the arc from the intersection point of the initial side to the intersection point of the terminal side. So this would represent the distance S, or the arc length. R represents the distance from the center of the circle to any point on the circle. So both of these distances would be considered R from the center of the circle to the point where the rays intersect the circle. And theta would be the angle from the initial side to the terminal side, represented in radians. We can then use the previous formula to come up with a new formula that allows us to calculate the arc length. The arc length theorem says for a circle of radius r, a central angle is a positive angle whose vertex is the center of a circle, of theta, radians subtends, and subtends means the rays pass through the circle, an arc whose length is s. That formula, which again, remember the formula we just discussed, was theta is equal to the arc length over r, the radius. If we solve that formula for s by multiplying both sides by r, what we end up getting is s is equal to r times theta. And again, a picture or a diagram would be if I have a circle and I have a central angle that subtends or intersects or passes through the circle, we can then calculate this distance along the arc by taking r, which is the radius, times theta, which is the angle, and theta needs to be in terms of radians, not degrees. So for our problem here, we have find the length of the arc of a circle of radius 4 meters subtended by a central angle of 0.5 radians. So again, we have a circle here, we have a central angle, we have the radius, which is the distance from the center of the circle to the intersection point of the ray and the circle, and this is going to be 4 meters. And then we have the angle, and the angle is going to be 0.5 radians. So in order to calculate that arc length, you're going to take S is equal to R times theta, which is equal to 4 times 0.5, which is equal to 2. And because the radius is in terms of meters, your arc length would also be in terms of meters. We should now be able to convert between degrees and radians since both are ways to measure angles. Circumference, or the measure of one complete revolution, can be represented with the formula capital C is equal to 2 times pi times r. One revolution around a unit circle, and a unit circle is a circle with a radius of 1, is C is equal to 2 pi. This means that one revolution around a unit circle is equal to 2 pi radians, or 360 degrees. Because one full revolution can be represented as 2 pi radians, or 360 degrees, we can then set 2 pi radians equal to 360 degrees. Dividing both sides by 2 allows us to get the formula pi radians is equal to 180 degrees. So if we were wanting to convert from radians to degrees, we would then say we were going to multiply the angle by 180 degrees over pi radians, and that would be the identity ratio we would use. If we wanted to convert from degrees to radians, we would then use the identity ratio pi radians over 180 degrees. We can now use that information in order to convert angles from degrees to radians. So let's go ahead and multiply by the correct identity ratio. In this case, since we're converting from degrees to radians, we would want to multiply by pi radians over 180 degrees. This will then reduce by a common unit of degrees in both the numerator and denominator, and from there we would want to go ahead and multiply across. This will give us a product of 80 pi over 180 radians. From there we would want to reduce the fraction to get a result of 4 pi over 9 radians. So that means 80 degrees is equal to 4 pi over 9 radians. Let's now go to the second problem where we have a negative 135 degrees. We're going to multiply by the same identity ratio, so pi radians over 180 degrees. And again, we would reduce by the common unit in both the numerator and denominator of degrees. Then multiplying across, we will get negative 135 pi over 180 radians. From here, we would go ahead and reduce, and reducing, we will get negative 3 pi over 4 radians. Now we're going to convert each of these angles that are in terms of radians to degrees. Once again, we're going to multiply by an identity ratio. This time we're going to multiply by 180 degrees over pi radians. These angles are in terms of radians while they are not labeled as such, and so we can reduce by the common unit of radians in both the numerator and denominator. This then gives us a final answer in terms of degrees. Now we will go ahead and multiply across. So I will also, by the way, reduce by a common factor of pi in both the numerator and denominator. So again, going back to the multiplication, we're going to multiply across with the fraction. So we'll get a product of negative 540 over 5 degrees. And so then we reduce the fraction, and what we end up getting is negative 108 degrees. Let's go to the second problem, and so we will again multiply by the same identity ratio. It's 180 degrees over pi radians. And again, the problem or the angle is in terms of radians, so we'll reduce by the common factor of pi and also the common unit of radians, leaving us with an answer in terms of degrees. Let's go ahead and multiply across. And so when we multiply across, we'll get 1,440 over 3 degrees. We then need to reduce this fraction, and so what we end up getting is 480 degrees. All right, guys, good luck.